Hello, in this video we're going to go over a problem from University of Maryland High School Math Competition in 2023. This is problem number 18. How many ordered triples of integers a, b, c satisfy the following system? ab plus c is equal to 17, a plus bc is equal to 19. This competition is a competition that I run annually in October. When you look at this problem, you want to exploit some symmetry. As you see, there's some symmetry involved here. If you add two equations, you'll get ab plus c plus a plus bc is equal to 17 plus 19, which is 36. Now, these two terms factor a b, so we get b times a plus c, and the other two terms are just a plus c. So that gives us a plus c times b plus 1 is equal to 36. Of course, that gives us some limitations on the values of b plus 1 and a plus c. It's probably better to use the fact that b plus 1 is a factor of 36 because that immediately gives you the values of b plus 1. That would give you too many values for b plus 1. In fact, if you write down the factorization of 36, that's 3 squared times 2 squared. There are 3 times 3, 9 positive factors, and double that, so 9 positive factors, and double that for negative integers, we get 18 factors here. So there are 18 possibilities for b. I don't want to go over that and see every single one of them, check every single one of them. Because of that, I'm going to apply a different strategy. So I'm going to take the difference of the two equations and see what I get. So take the bottom equation and subtract the top from that. That gives you 2. And this factors into, so this is something similar to what we had. This is b minus 1 and then c minus a. That is equal to 2. So if you multiply, we get bc minus ab minus c plus a. Now this tells us that b minus 1 is a factor of 2. So this is better. So b minus 1 divides 2. And we also know b plus 1 divides 36. So let's check the first one because this one is there is less possibilities for this one. So that means b minus 1 is equal to plus minus 1 or plus minus 2. So if we add 1 to each one of these, we get 2. If we add 1 to 1, if we add 1 to negative 1, we get 0. Add 1 to 2, we get 3. Add 1 to negative 2, we get negative 1. So let's check each one of these. 2 plus 1, does that divide 36? That does. So this is a potential answer for our problem. 0 plus 1, that's 1. Does that divide 36? Yes. 3 plus 1, that's 4. Does that divide 36? Yes. Minus 1 plus 1, that is 0. So that's a no. That does not divide 36. So there are 3 possibilities for b. b is either 2 or 0 or 3. Now let's take each one of these and rewrite the system and see how many solutions we get for each one of them. So ab plus c is equal to 17. And then I have a plus bc. So a plus bc is equal to 19. The next one is ab, so 0a plus c is equal to 17. And then a plus 0c is equal to 19. And finally, the last one is AB, which is 3A plus C is equal to 17. A plus 3C is equal to 19. Okay, let's solve each one of these and then see how many solutions we get. So for the first one, we can take the second one, multiply by 2, and subtract from the first one. We get 4C minus C is equal to 2 times 19, that's 38, minus 17. That gives us 21. So that gives us C is equal to 7. And once we get C equals 7, we can plug it into the first equation. We get 2a plus 7 is equal to 17, which means a equals 5. So a equals 5, C equals 7, and b equals 2. They do satisfy the system. You can check in the second equation and then you would see that in fact they satisfy the second equation as well, because you get 5 plus 2 times 7, which is 19. The second one, b equals 0, gives us c equals 17 and a equals 19. Of course, these do satisfy the system. Okay, so far we got two solutions. This one, we can multiply this one by 3 and subtract from the first one. We get 9c minus c, so that's 8c. 3 times 19, that is 57, minus 17, so that's 40. So we get 8c is equal to 40, so that gives us c equals 5. If c is 5, a is 19 minus 3 times c, so that's 4. And if we check in the first equation, we get 3 times 4 plus 5, which is 12 plus 5, so that's 17. So that's the other solution to this system. So we got exactly 3 solutions to the system. If you're interested in problems like this, make sure you subscribe to the channel. I will see you in the next video.